Hi folks, it's Mr. Mike here. So let's talk about Theorem 3. I'm starting today with just an empty circle with just a center. And I want to move with you from the start. Say we have something like that, okay? And we have that. So you know that would be, if that is 2x, that would be x. So, sorry, this is straight, right? So if that is 2x, that would be x, because the angle at the center is twice the angle at the circumference. Let's call this A, B, and C. All right. Now, let's take another color and say, but what if we draw another one there? If we draw another one, and say this is y, so that will be what? That will be 2y, because the angle at the center is twice the angle at the circumference. So how can we put all this together to come up with a different theorem now, right? So we can therefore say, if we have 2x plus 2y, we know that is going to give us 360. And so 360. So we know that x plus y will be equal to what? 180. So that would mean that this x plus y will be 180. So let us draw a new theorem. Now our new theorem will be, now this is a four-sided shape. It's a quadrilateral. It's a quadrilateral. So that means if we have any quadrilateral, so you have x, you have y, that's a quadrilateral, and these are opposite angles. As you see here, x and y are opposite. So we can say opposite angles of quadrilaterals add up to 180. Opposite angles. So we can say, therefore, taking this from the first calculation that we had here, so that would mean that we can say opposite angles of quadrilateral of a cyclic. So get that word. It's a cyclic quadrilateral. It's a cyclic quadrilateral. Why? Because all the vertices, all the corners are touching. It's a four-sided shape with all the corners touching the circumference. That's why it's called a cyclic quadrilateral. So I'll say the opposite angles of a cyclic quadrilateral add up to 180. So that is our theorem 3, right? That is our theorem 3. Our theorem 3 says the opposite angles of a cyclic quadrilateral are equal to 180. So if this is E, this is F, so that means E plus F is equal to 180. And don't forget, I don't need a center. There is no center now. In Theorem 3, there is no center. Okay? Theorem 1 and 2, there was a center. So we moved from Theorem 1 and 2 and to 3, and 4 is going to come shortly, but there is no center. So you can draw any cyclic quadrilateral as long as all the corners of that four-sided shape or figure touches the circumference. So that's it. Okay? That will be it for Theorem 3. And when you understand this, please send a message and say, Mr. Mike, I get it. I just need examples now to practice what I just learned. Thank you, guys. Theorem 4 is following shortly.